Imagine this, you're designing a vending machine. It needs to calculate the minimum number of coins to give back a change for any amount. Sounds simple, right? But as you dig deeper, you'll find it's not as easy as just grabbing the biggest coin. This is where the coin change problem comes in, a real world challenge that also happens to be a favorite in coding interviews. Alright, here's the plan. We'll solve this using dynamic programming. It sounds fancy, but all we are doing is breaking the problem down into smaller subproblems and solving them step by step. The key idea here is to use dynamic programming to minimize the number of points needed for any amount. This method ensures we solve the problem efficiently without trying every possible combination. When I first encountered this problem, I thought how hard it can be. Just pick the biggest coin until you hit the amount, right? Well, it turns out that strategy doesn't always work. And don't worry, it's not as scary as it sounds. And trust me, once you understand it, you'll feel like a coding superhero. Let's define a method named coin change that takes two input coins, an array of integers representing the available coin denomination, amount, the target amount we want to form using the fewest number of coins. This method returns an integer, which is either the minimum number of coins required or -1 if it's impossible to form the given amount. We create a dynamic programming array, a DP of size amount plus 1. The index I in this array represents the minimum number of coins needed to form the amount I. We initialize every element of the DP array to a large value, that is amount plus 1, which represents an impossible number of coins. This ensures that as we calculate the minimum coins, we can easily identify valid solution. To form an amount of 0, we need 0 coin. This serves as the base case for our dynamic programming approach. We start iterating from 1 up to the amount to calculate the minimum number of coins needed for each amount I. Each iteration of I represents solving the subproblem for that specific amount. For each amount I, we loop through all the available coin denomination in the coin array to determine which coin can contribute to the solution. And then we check if the coin's value is less than or equal to the current amount. If I is greater than coin, this coin can't be used for the current amount. If the coin can be used, we update DPI with the minimum of the current value of DPI, the best solution found so far. DPI minus coin plus 1, which represents using one more coin of the current denomination. If DP amount is still greater than amount after all calculation, it means forming the amount is impossible, so we return -1. Otherwise, DP amount contains the minimum number of coins required to form the target amount. Here's the quick recap. Initialize a DP array to store the minimum number of coins for each amount. Use a nested loop to fill the DP array by checking each coin and return the results based on final value. And there you have it, a clean, efficient solution to the coin change problem using dynamic programming in C#. I hope this breakdown made the concept crystal clear to you. If you have enjoyed this video, hit that like button and subscribe for more coding content. Have a problem you're stuck on, drop it in the comment and I'll cover it in the future video. Until next time, keep coding and stay awesome.